Now, building programs. So this would be the second item here in the list. And before we plug anything in, I want to explain it first, how that works. It's always the same way and how to choose this. There are lists within the OpenStudio app or the installation where all these building types and programs are defined, also schedules, and you can create your own. But of course it's easier, especially at the beginning, that you can choose from here, and you can see already the building programs here, they're all very commercial. There are mid-rise apartments, and these are maybe the ones which might fit the best, but I would like to be a bit more specific for certain rooms. And let's have a look on how that works. So you can choose from here. Here it was easy, we set this construction set. Here it's gonna be a bit more difficult. We can use again the selector, the list selector, and select from here. I just want to show you what are the different options are. Retail, strip mall, mid-rise apartment, primary school, hospital, outpatient, laboratory, warehouse, courthouse, large data center, full service restaurant, supermarket, and so on. Now it becomes a bit more complicated. Building program itself, it's I will turn this off again so it doesn't recalculate all the time. So if we plug this in here and we check the program, then we see now it has changed from the general office type to high-rise apartment. And now we don't know much more about what's in there. So this would be a way to choose a building program that basically assumes. So if you don't want to go room by room, you can also apply this to the whole thing. High-rise apartment, or let's say it's a mid-rise apartment. I could apply this and I probably get a quite good understanding of performance of my building. But like every room would be basically an average between the different room types. That's what I understand. But we can be more specific, and we can, for example, search by program. So we can take this search by program and add it here, and then see what would be a room program. So in the mid-rise apartment, there are several programs in here. There's the apartment, office, that would be like a study, and the corridor. So we could use some of these, and it's also a way then to add the vintage. Let's see how that changes. Not much. And we could also then filter by a keyword. So if we don't want to use the selector, then we could use. If we don't want to use the list selector, then we could use keywords to filter out. But I think this is much more usable, really. It's much more convenient to select from the list. That doesn't give us much choice here, I have to say. It's the same here. We could use the corridor probably. Retail, there's more in there. Strip mall, there are only types. And that you would need then to look up. Nothing else really fits to a small office, maybe. Small office. That could work. We could use that because here we have some room which could fit to our use. If I think about a small office, think of like a few people, could be almost like a family, but the usage might be different. And now also with like so many people working from home, the whole thing has shifted quite a lot. So a lot of people work from home. Anyway, so this is just a way on how you would need to start to think about, do you want to apply just a generic average kind of assumption to the whole building or to the program, or do I find something more specific which fits to my program? And that could be, for example, a room program from another type where it's probably similar. Don't trust me, because I just make assumptions here. I just make assumptions. So this is one way. We could go through here and see, okay, small hotel. Let's see what's in here. Laundry, meeting office, public restroom, guest room. That I could imagine this is almost like a bedroom. Let's see if this changes with the vintage. But yeah, we could maybe use some of these. Kitchen is difficult. I really have to say, kitchen is maybe small office. Is there any kitchen, dining, break room, classroom, closed office, conference room? There are other ways. What you can also do is to disconnect this here and then go into add a panel. and search for the keyword. That's also possible. So large hotel C, you can actually look for full service restaurant kitchen, hospital kitchen, large kitchen, primary school kitchen, quick service restaurant kitchen, secondary school kitchen. These are all like very large kitchen. They use a lot of energy for sure and needs a lot of cooling, heating not, but cooling. So also doesn't fit really our room program for the kitchen for a single family. So in that case, again, we could use the building program, the small office, no, the mid-rise apartment, and just use the apartment as the like a generic room program, or we build our own program. That's also possible. So we looked at the search program. That's the building program. This is the one we already looking at. And then we have this other tool which could help us to create a much more specific version. And then there are other ways to mix room programs by percentage or ratios, let's say. So you can put two different programs in there and then add the ratio. That might also work quite well. But let's try to recreate our own program, and maybe we achieve something which is more suitable for us in that case. So we give it a name. Kitchen base program. Let's use this as a base program. It's the mid-rise apartment. We could also maybe let's try this. We use a small hotel and we use the kitchen. No, I think we need to search it again. Primary school kitchen. Maybe let's try that. So we could use that as a base program, and then we need to provide more stuff, and these are optional. So we could say how many people. So we need a people component, people per area, and we can read here: create people object that can be used to create a program type or be assigned directly to a room. We need an occupancy schedule and the people per area. So how many people per area? It's gonna be hard, because how can we, per area we could say 2 or 3, and I'm not happy with this really. I would choose probably, well, we don't have to have that. Let's don't have a base program. And this is just an example, so we can think about this more. The occupancy schedule, that's tricky. The fractional schedule for the occupancy over the course of the year, the fractional values in this schedule will get multiplied by the people per area to yield the complete occupancy profile. So schedules are here, and this is the same game over and over again. We could search for a schedule with keywords. Let's do that. And then these are schedules, prefabricated schedules, but we could also create our own, because it's gonna be really hard to find a schedule for this. So what else could be a schedule? We could get a schedule from our example files. That could be some way to do it, or we create our own schedule. And we could have, it could be very simple, and we just think about how much is the kitchen used during a day and apply that to the whole year. That's how I understand it. So we could create our own schedule, and I'm just trying to. So we could look at the example files. If we go in the folder where we installed the Ladybug tools, then we can actually look at schedules, creating schedules, and we could choose something from here. Create a schedule. See, here's a weekly schedule. That could be very useful to use, and we can apply a name and so on. Let's try that. See, it's already prepared and used, but maybe let's recreate it ourselves. This is much better because we learn it right away. So how was that done? We can, if we look at the schedules, weekly schedule, this was the one. So we could say the kitchen is used every hour during a day in a certain way, and on holidays in different ways. And we apply this by using the gene pool, which is 24. So we need 24 hours to 24. We could do this as it is in the example. That's one way to do it. Or we just assume a number on how much is it used per day. That's also possible. So we could say we have the slider, which is a float number, and we could say Sunday kitchen is used the whole all 24 hours full time, which is for sure not. So we could say no, it's a very active kitchen. It's always in use, so it's used almost a half time of the day, or maybe just, let's say, a third of the day. And then we could apply much less for the kitchen during the other days. On Sunday it's a lot, and on the other days it's less, maybe just 0.1. That could be that's definitely a valid kind of way to do it. It's just an average of what that would be. So here we could go in here and edit and say the maximum is 1. It's not used in the night. From 0 to 7 it's not used. 7 it's gonna be used, maybe 2 hours, and then it's not used, and then it's used again by just one person cooking and maybe eating is in the same space, and then it's just one person, then there's nothing, and then there's nothing. So that could be a schedule for a day, and we could, if we average this, then we get 0.25. So that would represent something like this. So this is a way to do it, but this is also a valid way to do it. And let's keep this as an example here. We can keep this, but let's stick with this for now. It's more simple. So use on Sunday and Saturday it's the same, and then we have holiday. Holiday is also used more, and we can give it a name. Limit type, we can look at that another time. And this is our schedule, occupancy schedule. Let's delete this here. And there's more, the activity schedule. What type of activity is there? Sport, because people also create heat and so on. And then we have electrical lighting, could put a lighting. We have here equipment and lighting. Here the name is not necessary, don't have to have a name. Kitchen program, but it's always good to add a program. Oh, actually we don't need this. Kitchen program. We can also apply this right away so we can see what's happening. Program, and now if we look at program, we see that's the kitchen program. It's our custom-made program, and of course we would need to know the watts per area for this and the lighting schedule, and we could create the same schedule for what we did here. But we assume we have some daylight, so let's go a bit lower. We use it mostly during the day. Let's keep it like this. I'm just making things up here, just as an example. Of course, then you need to think a bit more. We call that light schedule. And of course, you can also look it up if there are already schedules which you could use. If they're already there, then why creating your own? But it's just a matter of testing it and learning how to do it. Watts per area. This is a bit tricky for me because I'm not sure. So for example, my kitchen has 2 or 3 LED lights. Could of course check the square meter. So we could go here and get the room and the attribute here. Oh, room, attribute, and then gross floor area. So we have 15 square meter. So we have 15 watts per area. So we have 15 square meter. So how I understand it is that you basically take the light you have in your kitchen. I, for example, have about 1, 2, 3, 4, 5, 6, 7 LED lights. So about 5 watt, let's say. These, I have something like this. So I could do this. I have about 7 LED lights with about 5, let's say 6, 5 to 10. So let's go for 6 or 8 because I have different ones. 6, 7, and multiply these divided by how much square meter? 15. Divided by around 15. 15 square meter. 3.2. That, yeah, I hope that should be okay. And okay, we're creating quite a detailed program here. Of course, then we could add the equipment, the electric equipment. It's gonna be the same game. Watts per area, schedule. You know, how much do you use it if you have a dishwasher? Things, if you have an oven, how much heating does that give, and so on. So it can get very, very detailed. But let's stay with this for now. It's just trying to give you an example. Or maybe let's do one more. It doesn't, just needs another schedule again, of course. Loads of schedules. Dishwasher 0.0. Nah, it's actually, yeah, I think similar. Light schedule is probably more. Let's go up here too. Again, I'm just making up numbers, but I would need to think a bit more in detail about that. Maybe like this. Let's assume it's almost as similar as the other one. That could be my schedule here. And then watts per area. I would need to check again what a dishwasher. Average dishwasher. I have a small dishwasher. Let's say it's 1,500 per area square meter. Let's use this again. Again, we're just exploring here. If you already know it better, let us know, because you know, we're learning better together. If we all learn together and help each other, that's the best. But yeah, I assume it's gonna be something like this, and I have only one dishwasher and per square meter, so this is 86. This is my electric equipment, and now we built a very, very detailed program already. So we could also have a hot water object. Where is this? Service hot water, create service hot water. I guess it's gonna be the same again. How much water? Here's a bit different per area. How much water per area, and the schedule. How much do you use it? But yeah, let's keep it for now what we have as a program, and let's see how that changes our output. Interesting. Okay, let's just run it. Let's look at the cooling again. Maximum is a bit difficult. Cooling energy, very little. That's strange. But yeah, we have some changes here in the equipment. Hot water. Now, if we would have put the hot water, we would have some kind of information. It's cooling. I guess it's because of the occupancy. We have quite a little occupancy. That's why we don't have so much heating necessary. That could be the case. That could be the thing. Or I did something wrong, but I don't think so. I guess it's really occupancy. For example, if I push this up, full occupied. Wait, let's stop the calculation. So electric equipment and lighting makes total sense here. Heating, no heating required. Let's check that data. You could also run that on one room. Maybe let's do that, because I feel that there's something wrong. I'm not sure why. So we could run that on one room as well, instead. And let's put this in here. No, we can't. So maybe we need to find the base program. Maybe it's important to get the basics there. Maybe we choose the mid-rise apartment. Just testing things, bear with me. So I'm just running one room, as you can see here. Heating energy is 0. I don't believe that. So maybe we need to have the base program in there, or we need to provide more information for this type. We need some energy for heating, and by putting it here we're losing this information. Yes, yeah, that's the problem. We somehow need to set the set point in order to calculate heating as well. It's in here in that base program, but it's not in. We need to provide that information as well. So this would be a relatively normal heating in the mid-rise apartment. But if we create our own program, then of course it's always better, of course, to have all of these filled in so we know exactly what we're using. I just want to get the heating right, and heating schedule, cooling schedule, temperature schedule for the cooling set point, humidity set point. Let's try to find one which is already prepared. Anything here we could reuse. Constantly repeat schedule, surge schedule, create interval schedule, create schedule limits. Maybe let's use a pre-made schedule for this, so we can look up a schedule instead, just as an optional way to do things. Search schedules, seasonal schedules. Let's search schedule, and maybe we can find the right one. Heating, okay. And now we can look at this, the output. Let's see what we have in here. Let's use the small office heating. We can reuse this one. Schedules. Small office heating schedule. And let's copy this here. It becomes a very detailed. Oh my god. Of course I lost my battery again. No battery for my camera. This video takes too long. Cooling, it doesn't matter. We don't need to see me. Primary school. Let's see. Large office, small office, cooling, office small. And now we should see some changes in the heating and cooling. If not, we need to investigate more. Yeah, so it's all not that simple. I was playing a bit with this here, with the heating and cooling schedule. I'm not 100% yet there, I think, but I'm getting some result which I think could work. It seems like that I'm missing some point here in the base program. If I detach this base program, then I get a quite different result here, which is a bit strange. It seems like I don't have any heating requirement, but a lot of cooling requirement. If I, however, set my base program, then it looks somehow more realistic. I need a lot more cooling though, and this is probably depends here on the temperature I'm setting here, the cooling schedule. If I go higher or lower, I'm still trying to figure it out. We'll get there, but I mean, this is kind of a way on how to create a custom program for your very specific room. We will go a bit deeper, and if somebody knows already how that works, I will try probably to set all these items as a homework for the next time and try to understand it better. We are trying to explain the principles here, and this is like one principle on how these like custom programs work. I would like to tell you more, but I'm also stuck a bit at the moment. There is for sure the need of setting the infiltration and ventilation, the hot water and gas equipments to understand more how that whole thing works, and understanding a bit more about the schedule, the cooling and heating schedule. They shouldn't be the same values here for the temperature, and I'm setting just like a constant temperature for both, which might not be ideal. I guess it's not how heating and cooling works. It also changes a lot with the occupancy schedule, so if that is set differently, then I also get different results. So for example, if I set all these to fully occupied, actually the people also create some heating, which then has an influence on the cooling and heating. If I remove that completely, it's interesting what's gonna happen. That would be interesting. Yeah, it has quite an influence. Then it assumes like a generic default value. It has an influence. It's more closer to the original kind of values, although here these overall values are different, and maybe also has something to do with this construction set. So I think we only can continue to explore in order to get better with it. I cannot find really good material to look it up, so I think we just need to continue exploring these items and understanding these better. Create a set point object that can be used to create a program type or be assigned directly to a room. It also doesn't tell us much on how it's used, this set point object. The set point object to describe temperature and humidity set point of the program. If none, the program type cannot be assigned to a room that is conditioned. So yeah, it's all a bit cryptic. If I set for example the heating temperature higher, constant value higher than the cooling, then it gives me an error. See, it kept everything, but it didn't recalculate. It says here the effect heating set point higher than effect cooling set point, increase that band if using unmixed air model. So we're a bit stuck here. I will use this as a point to do my homework and understand this a bit more. But in general, we're starting to create a custom program for our kitchen, and then we can reuse these things, of course, in other rooms. And I mean, this is just an example on how we could start with exploring these tools. So before we stop now, before we change, let me go back here and put something else. This needs to be higher, so let's go here. Let's first stop the calculation. Go here lower and set this to, let's say, 25. This is 21. 25. And so lighting sketch is very low because of the occupancy. So the occupancy for sure plays a big role in this. And yeah, I mean, I just set up something. This is just numbers, and it's just like really exploring the options here. Now let's go back and apply the whole model again, just to see how that looks like in the whole setup. And then before we stop, I want to I want to show how to get more data out of the model. If we compare that, it's getting pretty similar. I assume that I'm not completely wrong with what I'm setting here. Energy consumption 36. It's a bit higher than the rest, but it's also the kitchen. So it's higher than in the previous model. Energy intensity. Let's look at the cooling. That would be interesting. Cooling. Yeah, it's much higher. But yeah, we are just exploring here, so don't take these numbers for granted. We had just a generic type, but we need to be careful what the output really tells us, because this is the kitchen, so it could be also because of all these items and the schedule, there might be much more energy used for cooling. Anyway, so this is we're just exploring. Now, before we stop this video, let's look at how we can add more of these data points into our chart, so we can look at more data. So we have some hot water data now. That's interesting. Not sure where this is coming from. Probably from the dishwasher. Could be. Yeah, service hot water. Guess it's the dishwasher. Pump electric. That I cannot apply, but it's okay. Solar gain, we don't have solar gain, but I want to look at it. And that's why what we need in order to get these other points, especially the solar gain, for example, and the people gain, we need to set here the simulation parameters. And we can do that by going here and set simulation output and simulation parameters. And this let's stop that first before it's rerunning. Simulation parameters goes here, and the output needs to go here. And here we can just set what additional data streams we want to look at. True. Toggle. So whatever we want to look at, we need to set to true. We need to set the energy use because that's the main type. Otherwise, we will not see any of these. Let's just put everything so we get better understanding of everything. Gains and losses. This is also the sun hour, the solar gain and loss. Load type. Oh no, this is not. We can look at the load type in another video. And the report frequency we can set later, we can choose it here. So this is set, now we can rerun it. Now it's of course becoming much slower. We still have the same output here, but now we can actually check more stuff. What else do we have now? Electric pump, we already had that before. People gain, we have people gain, that is basically the energy from people. We have solar gain. That's a new item. Infiltration load, we can talk about this another time. And these are the items here, and other things we need to set additional tools in order to look at. But now we already have a bit more information. And I also want to show you that a building, for example, can have an influence on this output now, because we have the solar gain. So we can set, for example, a building as a shade object. Let's do that. So we can look at that and how does that influence our model. And we need to set this here. So let's get Honeybee shade object. The BWrap container. Can set one object. This is this object here. And we put this in here and put this into shades, and it will rerun automatically. Let's look at this chart, how it looks like at the moment and how it's changing. It doesn't let me move my screen. It's calculating. But yeah, you can see it changed from cooling is now less. We need less cooling because of the shading, and could look at other things. The heating now has probably changed a bit more. Now this building also needs, this room also needs more heating. Lighting depends on the schedule, really. That has little to do with it. But yeah, the solar gain has also changed quite a lot. It was higher up here. Just to make sure that you see the difference, I'm gonna move this building around and let it run again, so you can see how this influences the output here. Maybe let's set it closer and let's see what it does. Yeah, you can see now this building has a huge influence on the solar gain here. It's much less now during the time where there's more sunlight. And yeah, that's how you can set more, that's how you can look at more of these data streams in the balance tool. Pretty cool. It's pretty cool. Okay, next time we try to wrap up this custom program, and I hope I can tell you more about it if somebody knows more about it, how it works. You know, with the problem with Ladybug, with the Ladybug tools and Honeybee, it's very specialized. You need to almost be an engineer to understand everything. I try to get there, I try to really understand it, but I'm not an engineer. And that's why I'm throwing it out there. And if you know more, let us know. But I'm just trying to put a puzzle together here and see how it works. And I will read about it, so I can hopefully tell you more about how this heating and how the set point works. I haven't found really a good explanation for it at the moment. Maybe I need to myself look at some other tutorials about it. But what I'm trying to show you is how the process works. I would love to actually examine this mid-rise apartment schedule a bit more, or the program more, to understand what data is actually in here which influences my custom program, and how can I fully control it. And maybe it's all about like just really understand this better, the set point, but to make it much more detailed, probably these items need to be set as well. So yeah, well, that's it for this time. I hope you're not completely freaking out. We will get there. It's just a matter of testing, trial and error. I think I have a pretty good idea already, but these smaller items, these little bits, they're just very, very difficult to get a grip on and really to understand how they should be set to be realistic enough. And I think we're in a good way. Okay. Sorry, my battery for my camera got dead again, and I have no other one. So I need to say goodbye without me being in the view, but it doesn't matter really. Okay, see you next time.